excited to be here today, talk to you about some work that I had my hand in while I was at the University of Nebraska over the last 10 years or so. So we all know that large river systems globally have experienced a loss of ecological function. This comes in a variety of anthropogenic impacts from dam installation, channelization, water withdrawals for irrigation, you name it. So a lot of these large-scale modifications have resulted in a loss of connectivity, hydrological changes, manipulating the flow regime, and so on. Well, the Missouri River is no stranger to these large-scale impacts. This is actually what the Missouri River looked like back prior to some of these large-scale impacts. So we have a very dynamic system. You have an expansive floodplain, braided channels, backwater areas, and so on and so forth. So just a real heterogeneous habitat or environment with complexity and various habitat characteristics. But we began to change that over time. So beginning in the 40s, we constructed reservoirs in the upper part of the Missouri River and then began channelizing the lower portion. And this is what we're working with present day. So this is the channelized Missouri River. It's a fairly homogeneous environment with relatively uniform depths and velocities. We have a pretty consistent channel width of about 200 meters. The inside bends are largely filled with these wing dikes that divert water to the outside bend, where you have this armored rock revetment to, again, maintain kind of a self-scouring channel for navigation. So we have these broad-scale human impacts to this large river system. And it begs the question, how do these physical changes impact fishes within the Missouri River? So ideal organism to study, or group of organism, are catfishes. Catfishes are found, both channel and flathead catfish are found throughout the Missouri River system. They're native to the lower portion. They resemble an equilibrium life history strategist where they prefer resource and environmental stability. Their abundance and size structure varies, at least anecdotally, and it's very important from a recreational standpoint. So the Nebraska Game and Parks Commission was really interested in understanding how these various physical changes along the Missouri River has impacted both channel and flathead catfish. So we wanted to examine population dynamics in 4 distinct physical segments of the Missouri River that borders the eastern part of Nebraska. And those segments are shown here in this map of the eastern side of Nebraska. So essentially there's 2 sections. We have an unchannelized part of the Missouri River and a channelized. And then each one of those sections are further broken down to an upper unchannelized, a lower unchannelized, shown in these 2 red circles here. The upper unchannelized is kind of sandwiched between these 2 reservoirs, and then the lower unchannelized would be from the lowermost dam downstream to where the channelization process starts to begin. So then in the channelized river, we have the upper channelized going down to the Platte River confluence, and the lower channelized, which would be down to the Kansas-Nebraska state border. So here's just a few pictures of what some of the physical characteristics look like for these habitats or these segments. This would be the upper unchannelized region. It's a very pretty area. You see a channel, it's a braided system, but it is impacted by upstream deep water releases from the reservoir, so it's much more of a cool, clear water type of environment. Here's the lower unchannelized, again, very braided, shallow system, but a lot of historic floodplain and backwater habitat has been eliminated, kind of tilled up for agriculture and whatnot. Then we move down to the channelized river. So this is right around Sioux City, Iowa, where the channelization process begins. Again, we're constricting flow, creating this self-scouring channel for navigation. And then we work our way down to the lower channelized river. So this is where the Platte River enters into the Missouri River. So from this point down, we do have some altered sediment dynamics, increase in discharge just from the influx of this large river system that moves across Nebraska. But as far as sampling catfish, we're using 2 sampling gears. We're using baited hoop nets, using scrap cheese, primarily targeting channel catfish, and then low-frequency electrofishing, aided with a chase boat, primarily targeting flathead catfish. So I'm going to be talking about this long-term assessment that we've had over the last 10 years, so 2009 through 2018. Again, we're looking at these 4 distinct segments, and within each segment, we randomly select 6 river bends to do sampling each year. So within those segments, within those bends, we run 10 hoop nets, evenly distributed between the inside and the outside bend, come back a few weeks later and have 8 electrofishing runs. So as far as data collection and what we're looking at, comparing among the segments, we're looking at discharge and then a suite of population dynamic rates. So we can move into some results. We had a very distinct water year in 2011. I'm sure most of you are familiar with the events that occurred. So we had some substantial flooding, which kind of provided a novel opportunity to look at this very regulated river when you actually have some floodplain connectivity. So this is what the flood actually looked like. You can see the channelized portion over on the left-hand side of this figure, and then this expansiveness of water. So very high magnitude in the flooding. And what was unique was that the duration of this flooding actually was like a 3 to 4 month time period. So this was all inundated for a very long time. So I'm just going to go through some various catch through time. So this shows each of our different segments, our 2 unchannelized regions up on the 2 top figures, and then our channelized on the bottom. So we did have some significant differences among the segments with all the years combined. But we did see some kind of unique trends through time when we look at individual years. So generally speaking, we had some declines in catch rates. So these figures, the y-axis is just the overall catch, and then, excuse me, the previous figure here, we had the mean annual catch per unit effort, the numbers in each of those bars. Just thought it'd be easier to share with you just our total catch. But again, nonetheless, we had this decline in catch through time. And if you note, in 2011, we didn't have any sampling that was conducted, so we weren't allowed to actually be out sampling for catfish on the river during that flood period. But in the years following the flood, we saw some pretty big spikes in our catch rates in all of our segments. Generally speaking, for channel catfish, we see very few channel catfish captured in the lower channelized segment of the Missouri River. The highest densities occurred in the upper channelized, and then we had kind of some moderate densities in the unchannelized section. I overlaid relative weight onto these figures, so those are the black dots. Thought it was kind of interesting in that we were seeing somewhat of a density-dependent type of effect going on. So in the years where we had the lowest catch rates, we actually saw fish in the best condition. This figure is showing recruitment. So the y-axis is the recruitment variability index. So it's an index that values range from -1 with like no and incomplete recruitment up to 1 where you have kind of consistent high recruitment. So we had some variability in recruitment through time with the exception of the upper channelized where we had fairly consistent recruitment rates. I guess one thing to note is that these bars represent fish that have been recruited to the gear. So that typically occurs around age 2 or age 3, depending on growth rates. So these peaks that you see are, again, kind of in response, well, they are in response to that 2011 flood event. So we had a high amount of recruitment initially following the flood, and then we see kind of a decline thereafter, similar to our catch rates that I showed you from the previous figure. Just some additional catch statistics from channel catfish. Total annual mortality varied, so we had lower mortality in the upper unchannelized and then kind of increasing as you move downstream. Again, that corresponded with maximum age and growth rates, so you had fast-growing, shorter-lived fish in the lower channelized and our kind of slower-growing, older fish in the upper unchannelized. Moving on to flathead catfish. We actually see very few flatheads in the unchannelized Missouri River, so almost no flatheads in the upper unchannelized. We had a few more in the lower unchannelized, but in recent years, our catch rates have been almost non-existent. Lots of flathead catfish in the channelized Missouri River, particularly the lower channelized. we see, I mean, just a plethora of catfish of all sizes, ranging from, great big 70, 80 pounders down to, juveniles. Condition, we didn't see those same types of responses as we saw with channel catfish. Relative weight was pretty consistent through time with a few anomalies in certain years. For flathead catfish recruitment, it was pretty variable in that lower unchannelized segment, but pretty consistent in both of the channelized sections. Some additional catch statistics for flathead catfish. It's pretty nice. Just a caveat to this is, so we're using pectoral spines for our age assignments, and we're only collecting spines from flathead catfish that are 800 millimeters or less. So these data aren't probably an accurate depiction of what our total annual mortality and maximum age estimates are. But again, I guess it gives you an idea of what the data that we had in hand. And probably the most interesting thing from our growth perspective is that fish in the upper unchannelized, the few fish that we had, grow really slowly compared to our other three segments. All right, so let's just kind of summarize some of this information. Here's my conceptual diagram of the Missouri River with our 4 sampling segments. For channel catfish, we saw very low abundance, small size structure in the lower channelized river. We had very high mortality rates. Fish are growing very quickly, the smaller size immature fish, and that changes as you move upstream, or you have a little bit higher abundance in our upper channelized, size structure begins to increase a little bit, and then our 2 unchannelized section, where you have somewhat of a moderate density, larger size structure population. For flathead catfish, we kind of see an inverse relationship, right, where we have really abundant populations down in the lower channelized, pretty high abundance still in the upper channelized, and then very few fish up in these unchannelized stretches. So it's kind of an interesting dynamic seeing how both flathead and channel catfish are orienting themselves across this regulated river. A couple things to note. So there's only one true barrier for connectivity or for movement for these 4 different segments, and that's the dam that exists between the upper and lower unchannelized Missouri River. So these fish have the capability to move amongst these 3 lower segments. Despite that ability, we still see these very distinct population dynamics. So the physical characteristics, the environment in which the fish are inhibiting are directly responsible for the dynamic rates that we're observing. We did see some potential negative interactions, so particularly when we're looking down to this lower channelized section where we had this high abundance of flathead catfish corresponding to very few channel catfish. That's kind of an interesting anecdote in and of itself. We look at some other large river systems like the Mississippi, for example. You have a little bit more habitat complexity. You might see these fish partitioned in different habitat types. So, channel catfish might be more in the slack water, shallow water, or backwater habitats, where you find flatheads into more of the main channel border habitat. Well, in the lower Missouri River, we don't have that option, right? It's such a homogeneous system. These fish don't really have the ability to partition out at all. And we're seeing that flathead catfish can outcompete channel catfish when they're coexisting in these same environments. And then we did see some kind of interesting density-dependent type of mechanisms going on, which again is interesting in such a large river system. We don't typically see those types of responses. As far as temporal effects go, we had this substantial flood that occurred throughout our 10-year time period. We saw some pretty positive effects initially. So we had a lot of age 0 reproduction, recruitment. We saw an increase in abundance for a catfish species. And some other studies saw some positive effects as well. So Stephenson et al. In 2014 showed an increase in species composition and age 0 fish production. Hoagberg and Pegg was looking at flathead catfish diet. Saw that flathead catfish had high condition in 2011 when they're out sampling on the floodplain. Stomachs were much more full and had a wider breadth of diet items. So again, just kind of an initial positive response. However, we saw a bit of a lag effect where we started to see some negative consequences occurring in the subsequent years. We did see some physical changes to the Missouri River, so there was some additional scouring that occurred in response to the flood, some potential additional loss of whatever shallow water habitat was available. You can see just this additional deposition of sediment along the banks, so you had these extreme high banks from just this tremendous amount of sediment that was deposited. We did see an overall reduction in small fishes in the subsequent years following the flood. Stephenson Messel, working with pallid sturgeon, saw a condition of pallid sturgeon dramatically decline after 2014. A quote from their paper said pallid sturgeon were captured in a visually emaciated condition. But things began to rebound, right? The Missouri River began to approach an equilibrium again, and we saw increases in smaller fish. Condition of some of these large fishes like sturgeon began to rebound in 2017, 2018. Then we had another event happen. Anybody know what happened in 2019? Another flood. This flood actually topped the historic levels that were broken in 2011. So a higher magnitude and even longer duration flood than in 2011. So it's yet to be seen kind of the ramifications of another flood of this magnitude. But as far as overall implications go, we saw modifications to the river system has impacted fish populations in different ways. So different or varying degrees of physical alteration resulted in different dynamic rate functions. We saw extreme flow disrupting kind of the status quo ecological function of the Missouri River, eventually returning to a bit of an equilibrium, but we don't know what impact these large-scale events could have if they're going to continue to occur more frequently, as predicted by various climate change models. That could have a significant impact on equilibrium type of life history strategists, where they prefer more of a stable environmental conditions. So finally, there's a need for both regional and interjurisdictional management if we're going to actively manage for catfish species. So for example, if Nebraska wanted to try and create a regulation to increase abundance of channel catfish in the lower channelized river, well, creating one statewide regulation or one Missouri River specific regulation is going to impact catfish in these other segments differently as compared to just one specific regulation. Similarly, the Missouri River flows and borders several other states, so without a true collaborative effort to try and come to a consensus on how catfish are going to be managed, we're probably not going to achieve any sort of desired results as well. So with that, there's a lot of people to thank. There's certainly the Nebraska Game and Parks Commission for funding this project. We've had several graduate students answering various questions related to this catfish work that's been done, as well as an army of technicians that collected data over the years. So with that, happy to facilitate any questions.
How do you think like the habitat differences amongst the reaches might influence the catchability of your gears? And in my mind, I'm wondering about like water connectivity. Does that vary a lot amongst the reaches, and how that might actually impact the catches of flatheads as much as their actual abundance?
Yeah, even with the habitat changes, like in response to the flood, it's still a very homogenized system. There's not a lot of complexity. Certainly there is some variability in catch rates, but I don't think it largely has impacted our catch rates through time. I think we still have the ability to sample the habitat in a similar way each year, but yeah, it's hard to say with catch rates and efficiencies.
Okay, we're going to move on. Thank you.
Yep.